This is the brief on the elastic interdependency of material constants. So when we're looking at how a material deforms, right, we use four main constants: Young's modulus, Poisson's ratio, bulk modulus, and shear modulus. And the key thing to get is that these are all tied together. You can't just change one without affecting all the others. Okay, so first up, all four of these just describe the basic relationship between stress and strain in a material. You've got Young's modulus and Poisson's ratio, which define how strain relates to stress, but then you have the bulk and shear moduli, which split the material's response into two distinct behaviors: how it resists a change in volume and how it resists a change in shape. And here's the real trick, the second point. This relationship isn't arbitrary. They're all describing the exact same physical stiffness. This means if you define any two of these constants, the other two are automatically locked in. You just can't choose them independently. Finally, you can see this really clearly in materials like rubber, which are nearly incompressible. In this extreme case, the bulk modulus is way higher than the shear modulus, so two things happen at once. Poisson's ratio approaches its max of 0.5, and Young's modulus ends up being about 3 times the shear modulus. This tells us that for something like rubber, its overall stiffness is dictated entirely by how hard it is to change its shape. It's clear these four elastic constants are fundamentally linked, showing how a material's resistance to changing its volume really governs its overall stiffness.